4 samples and data point in this data points represents a range from 1 to 50. We shall utilize the usual fit function. Each level's input sequence must handle 1616 patches. We are now working on the 16160 step. For the first iteration, the input sequence must be executed in 1616 batches with a loss of 0.0011 loss shrinks in size. After that, the anticipated value must be converted to the unnormalized value. In addition, a normalized value of the predicted value is generated and added to a data set of 114917 sets because the blue line represents the training data, while the orange line indicates the predicted value of the mode. We will use the forecast generator to create, build, and fit an LSTM model for forecasting with 5 epochs provided. The data will be trained for 1795 steps. Each step yields a 7.7437 E for loss. The initial evaluation batch has a standard length of 50. To forecast and simulate the current projection, the current batch is used. Forecast add and then inverse translate will be used to predict the storage. The inverse transformation will be used to normalize data to true values, which is shown in the shuffler. In this, we have this the input sequence with calculate 1668 batches. In 1616 batches with a loss of 0. We have loss of 0.0011. In addition, the normalized value is predicted generated in a 114917 dash. Usually, we have an LSTM model for forecasting with 5 epochs provided, and it's trained for 1795 steps. Each step yields a 7.7437 loss. And the length and the evaluation bed and the length of 50. The closing price of the original stamps from 0.02114917. The initial data set range from 0 to 114917. The forecasting index ranges from 114912 to 114995. We will only have the prediction from now on. The model's predicted values are shown, and I created a new frame with the rent nominal included. The variable rent nominal is represented, the prediction is depicted. When we put it to the text, it fails to forecast the true one during the model examination. The data sets will be incorporated into the new closing price. The model is based on the input sequence of the new value. Only the most recent 50 data points will be included in the new input value. Accurate forecasting values can be forecasted. These are the closing values that we have shown from ordinal spams to the index ranges, which is 0.20 to 114917, and it ranges to 114995. We will only have this prediction from now on, and the model's predicted values are shown, and I created a new frame with the trend nominal included. This graph shown the redesign mode. It has input layer, LSTM layers, and dropout layers. And it has two input layers, two LSTM layers, two dropout layers, and one output. Uh, Updated parameters. Percentage of data for testing is 0.1. Layers of LSTM. It has one input layer, two dropout layers, three LSTM layers, one dense layer. Number of neurons in each LSTM layer. All the three LSTM layers have 64 neurons each. Dropout layers, two dropout layers, and the percentage to drop is 0.5. The length of the time series input sequence is 50. Batch size of for training is 64. Number of epochs for training is 10. Results. The dataset is subjected to exploratory data analysis. Data is split and the normalization is performed. Time series generator is built to train the data. Three LSTM layers and the two dropout layers are used to generate the LSTM model. I used 10 epochs for model training, which I changed from part 4. The training data loss is 8.1049E04. The anticipated values for rent nominal are greater than the original values after the forecasting. And these are the results which shows for the recreating data flow. The dataset is subjected to exploratory data analysis. Data is split and the normalization is performed. A time series generator is built to train the data. Three LSTM layers and two dropout layers are used to generate the LSTM model. I used 10 epochs for model training, which I changed for part 4. The training data loss is 08.1049E04. The anticipated values for rent nominal are greater than the original values after the forecasting. To the values of rent nominal are greater in forecasting than in original values as projected, which is not the case in part 4. The error value decreases as the number of neurons in the LSTM layer and the number of epochs raise, as shown in part 5, making the changes some progress is made.